The question you were just doing right now.
Oh, not here.
لا
Okay.
not here.
Okay. So
أنا
in this,
بتذكر يعني فرق
okay.
كنت عم بلش عملنا هيك شيء إنه we elongated the axis وعملنا f times d أو لا ما خصها.
بس نحن بعد ما عملنا المومنت now. We'll do it
ما
now.
فينا نعمل summation مثلا.
Look, you want to do now some of moments about point C. Okay? When you want to do the moment of a force about C, you need to determine the distance between the force and C. Okay? So for example, let us take the first force here. The force of 200 lb. So first you should select a positive direction for your moment. Let's say we considered that the clockwise is positive. Okay? For the 200 lb force, how you can find its moment about C? You need to find the projected distance from C to the line of action of the force. So what is the line of action of the force? It is the vertical. Okay? So I extend it Y to be able to project, to find the distance of projection from C to the line of action of the force. So I can do like this, the perpendicular. Then the distance is equal to 2 feet. Another method, if you want, you can do from C a parallel to the force, and then say that the distance is 2. You can also do this. Okay? So, or you do from C a parallel to the force, and then you find the distance between the two lines, or you extend the line of the force and you draw from C a perpendicular to the line of action of the force, you get the perpendicular distance. And here, for example, if you displace the 200 force along this line, nothing will change. This is why you can extend the line.
So if you want to find the moment, we can do 200 times 2 plus مثلا 150 times 4, 100 times 6.
Yes, of course. When we
So
want to
this is
find,
another method.
no, it's not another method. The idea is that you are summing the moments. Okay? Now I am finding just the moment of the first force, which is of 200 lb. Then I should add the moment of the second force, which is 150. Then the moment.
Okay.
Okay? So
Okay.
I will find the moment of each one, then I do the summation.
Okay.
Or you can directly sum, of course, you can directly do the summation and you put like this, sum of moments about C. First, since there are, you have selected the clockwise positive direction, and these forces are doing a moment in clockwise direction, so you can take plus, so for the first it's plus 200 times 2, for the second it's plus 150 times, what is the distance for 150? So it's this distance. If I take the parallel from C to the force, this is the distance, it's 4. Okay, so plus 150 times 4 plus 100 times 6. Now I still have the final force at B. The force at B, I have two methods to get its moment. Okay, the first one is to try to find the perpendicular distance from C to the line of action of the force, but it seems here that it's a little bit complex. Okay, because it's not straightforward. So whenever it's complex to find the perpendicular distance, divide your force into two components. This is the easiest way. So you can divide your force at B into two components. Already you have divided the force, so you have a y component. For the y component, the moment is clockwise and the distance is very simple, it is 8. While for the x component, okay, who will tell me what is the moment of the x component about C? First, what is the distance?
6.
6, very good. Because if you take the line of action of the force, the x component of the force, this is its line of action. And if you draw the perpendicular from C to the line of action, this is the perpendicular, it's equal to 6 feet. Okay, so I should multiply the x force by 6. Now, concerning the direction, so I do the right hand rule. From the right hand rule, it's also, or I can do it simply with my hand. Yani it's very simple in 2D, like this. You do this. It's trying to turn in clockwise direction about C. So it's plus. So if I continue, it's plus the y component. So the y component, I will take it in absolute value here, okay? Because the moment of it is positive. So it's plus 500 times 3 over 5 times 8. And it's plus the x component, so absolute value, x is already positive. So plus 500 times 4 over 5 times 6. And in this way, I get the resulting moment, okay? And since all forces are producing clockwise moments, so of course the resulting moment will be clockwise.
Doctor,
Yes?
can you repeat why we multiplied them by 6 and 8?
Yes, of course. Because look, this force here can be divided into two components. One component along x and one component along y, okay? Let us start with the y component. For the y component, what is the distance from C? To know what is the distance from C, okay? What you do is, or you take from C a parallel to the force, and you find the distance between the two lines. What is the distance between the two lines? It's this whole distance. It is 2 times 4, it's 8, okay? Or you can extend the line of action of the force and draw the perpendicular from C towards this line. It will also show you that this distance is equal to this one, is equal to 8, okay? This is for the y component. Now, for x component, you do the same analogy. You say, what is the line of action of the force along x? This is its line of action. If I draw the perpendicular from C to this line, what will be the distance? The perpendicular distance will be 6, so I should multiply by 6. Okay?
Yes, it's clear now.
Or you can also take a parallel line to the force and say that the distance between the two is equal to this one, which is 6. Okay, so now what we did, we reduced the system to one force, one couple at point C. Now, I will add a question for you. I will tell you, I want to reduce my system to a single force, one single force, okay, on a C line. Who can tell me what can I do? So this is the resulting moment. So I end up with M resultant at C. So this is M resultant at point C, and this is F resultant at C. If I want to reduce now to a single force my system, what should I do?
I should calculate the distance D.
Very good. What will be the distance D? If I want to displace my force in a way to just have a single force, I don't need a couple. I want to find what should be the distance D in order to replace my system by one equivalent force, like this.
Doctor,
Yes.
but we can move it like this. I thought we need to do it in components and we take only the perpendicular.
Bravo. Yes, exactly. We will only take the component producing the moment, but you will displace the force as it is. But which component will produce the moment? The x component or the y component?
The x component.
The x component. So once you want to do your calculation here, you will say that when I displace my force on line AC, the y component will not produce any moment because it's passing by C. So the component that will do a moment about C is the x component. And then to find what will be the distance needed to have a single force, you will say that I should displace my force in a way to produce the same moment about C. So what is the condition? M resultant at C should be equal to F resultant in X, okay, times D. So I deduce that the distance D should be equal to resulting moment at C over FRX component. It's not over FR because not the whole force will produce a moment about C, only its X component, okay? The Y component is not producing a moment about C. This is why I divide by FRX, okay?
Doctor, where is FRX in the figure?
FRX in the figure is this one. I have, this is FRC. As you can see, it's inclined. FRX, you can decompose it into two components. One along X, already you have calculated it, okay? Because when you calculated FRC, you divided it into FRX and FRY, okay? So now, when you displace your force, as you can see, since you are displacing it on AC, when you displace it, the Y component will not do anything because look, the Y component is always passing by C, so it cannot produce a moment about C. But what will make the change is the X component, because when you displace along AC, the FRX component will produce a moment about C. So what will be the distance to move in order to not need a couple, to just represent my system by a single force? The condition to have a single force is that this force should produce the same moment about C. And the moment about C is already calculated. It is M resultant about C. So you will set the condition that MRC is equal to the moment produced by the single force. And the single force will only have a moment due to the X component because the Y component passes by C, so it cannot produce a moment about C. So you can say now that this single force will produce a moment equal to FRX times the distance of displacement. From here, from this condition, you can get what should be the distance D to displace your force on AC in order to get equivalent system with just a single force.
Doctor,
Yes.
in the chapter, we had a slide where we moved the force for a distance, but there is a moment that stayed.
Look,
don't
yes,
know.
I will solve this problem with you. Next time you will solve it. I forgot it. Okay.
No,
You will
I
solve
mean
it
here.
together. You mean the plate with X and Y?
No, there's a slide. I don't know. There's a slide we did it.
Oh, we did it together.
Yes.
Okay.
You were explaining. We can. Okay, when we get the components and we want to move through a distance.
Yeah.
The-
Okay. The one that remains is a parallel moment, parallel to the force. This one you cannot remove it.
Yes. So here I am just
Here,
asking.
no. Here it's not the case. You know why? Because you are in a 2D problem. In a 2D problem, look, how is your moment vector here? It's perpendicular to the screen. Your moment vector is perpendicular to the force. Whenever your moment and force are perpendicular, then you can remove the couple by displacing the force. But in 3D, you have the possibility to end up with a moment and a force resultant that are not perpendicular. In this case, you can only reduce to a force and moment that are parallel.
In 2D, you said that you always get them
Yes, in
perpendicular.
2D always you can replace by a single force. And this is a 2D problem.
Thank you, Doctor.
Okay, guys, so any other question before we close? Yeah, we will practice more on this next time, okay?
Doctor,
Yes.
I wanted to ask you if you had any extra exercises we can practice on for chapter 2 and chapter 3, because I'm having a lot of difficulty solving them because every time we do an exercise, there's a different way of doing it and a different way of thinking. I'm not feeling very confident in problem solving without actually
Okay.
having the solution next
So,
to me.
Marisa, did you
So
try
I
to
don't know
do?
what to do.
Did you try to do the sample test I posted for you?
Yes.
You were able to do it?
Yes, most of it, yes. Sometimes بعلق شوي on the method, but
Okay.
no, it's okay.
Look,
But I don't know what to do other than this because maybe we need more
no need to do,
exercises.
no need to do other things. You need to be confident about these problems. Okay. So if you don't know, if you felt that you have a difficulty, repeat it. Because look, the ideas in the exam, I will not give you new ideas, very complex ideas. Everything will be similar to what we do together. So just repeat these problems to be confident in solving them, and you will do well. So it's very close to the type of problems in the sample test. And as you can see, the sample test is much more straightforward than the problems we solved
Yes, it
together.
is.
Okay. So, but all ideas that can be in the exam are in these problems. So you can see that in one problem here, we can solve several questions in a sample test. Okay, that's it. So just if
Doctor,
you know to solve these problems, no need to do extra practice, really. And we did a lot of problems together. Just be confident about the methods, practice with this problem, it's enough.
دكتور كان في حلينا نحن وقتها a geometrical problem عملنا centroid center of gravity thing. هي حيكون حتجيب لنا هيك قصص يعني لازم نعرف هيك geometrical concepts ولا ما في شيء جديد؟
صراحة مش لا ما في قصص هيك معقدة. Don't worry. No.
Okay, thank you.
It's like the style of the sample test. This is the type of questions. يعني مثل ما شفتوا هن parts of the problems. ما فيني اجيب لكم problem كبير يعني يعني even I gave you 3D problems بالexam, but it is يعني the time I solve it and I see what is the time needed. The يعني maximum problem حياخدكم 10 minutes. أكبر problem.
Okay, thank you, doctor. And do you know how long is the test on Saturday?
Yes, the test is 13 questions. I'm thinking of giving 50 or 55 minutes. حاعطيكم 55 to relax يعني ما بدي اضغطكم بالوقت. Okay, I will give you 55 minutes. إذا صار معكم problems of connections أو شيء إنه ما تعلقوا كتير. 55 minutes, 13 questions. I solved it myself in test. أخذني شي 40 minutes. So I will give you additional 15 minutes for you. Okay?
Okay, doctor.
But please يعني concentrate on your exam. أول شيء when you find an answer for your problem, you directly put it on Blackboard. You should fill the boxes in Blackboard. I don't want to have disagreement between what is in Blackboard and in your draft. This is the most important thing. Okay? And I will...
Doctor?
yes.
Sorry.
Yes.
Is backtracking allowed or?
No, it's not allowed. This is why take your time. يعني or you know or you don't know. يعني just focus 1 minute. If you don't see the solution in your mind, skip it. Okay?
Doctor, is there any chance you could give us 60 minutes instead of 55?
already it needs...
Please.
Look, already
Doctor,
it needs 50 and gave you 5 minutes in more.
I need to tell you something.
Please, doctor. Now we're stressing about this test.
Doctor, the idea of seeing the time in front of you on Blackboard أنا gives me stress. أنا بس شوف الوقت عم بيمشي بصير ما بقعد أعرف أفكر يعني بدي دقيقتين ثلاثة.
أول شيء no need to stress. I don't correct on the answer. Okay? أنا بفهم لو I correct on the answer تكونوا stressed. I correct your draft. يعني even if you don't get to the final solution, you will get partial grade. So be relaxed completely and do what you know. Okay? يعني even if you didn't reach the final state, you will get maybe 80% of the grade. And there is nothing to worry about. I will follow your draft. I will put for you partial grades. I gave you additional 5 minutes. يعني already I tried to feel you comfortable. So please relax. And 55 minutes is enough. إذا بعد 60 صار over يعني بده يصير في ساعتها cheating و I prefer to give time يعني ما بدي اضغطكم بالوقت كتير بس I cannot give 60 minutes. It's long يعني it's more than enough 55 minutes.
Okay, thank you, doctor.
Okay, guys, good luck. يلا, we'll talk about...
Thank you, doctor.
Next
Thank
time.
you, doctor.
Bye.